Hey, this is Aaron from Wirdum. I interviewed Jeremy Rubin on his check template verify proposal. Can you please introduce yourself for my listeners, Jeremy?
So my name is Jeremy Rubin. I am a contributor to Bitcoin Core. I have been involved in the Bitcoin community since maybe 2013. I did some projects which were notable at the time, one of which was called Tidbit, which was web advertising, but replaced with cryptocurrency mining. And we got in a bunch of legal trouble with that. That launched me on a big journey in the MIT community, doing a bunch of projects, distributing Bitcoin, doing the MIT Bitcoin Expo, the MIT Digital Currency Initiative, launching Scaling Bitcoin conference series. And since 2016, I've just been a Bitcoin contributor on and off again, worked on a couple different projects, and most recently have been focused on something called Check Template Verify.
Yeah, and I think the projects you have been working on are pretty diverse, right?
I've had my focus kind of all across the code base, from both the protocol development and research side to things that are a little bit more applied, like signature caching.
Yeah, so recently it seems like you've been on some sort of promotion tour for CTV. Is this a fair term?
I think that's fair.
Is it a promotion term?
Yeah, I mean, it's really an awareness campaign, if you will, trying to raise the dialogue and discourse around smart contracting on Bitcoin, getting people sort of informed about what the new technology is that they could use, how it could be used, what sort of impacts that might have on the ecosystem, and starting to think about if it makes sense for the community to adopt something like this.
So that was a workshop, I think, in San Francisco.
So the workshop was primarily engineering focused. There's like a transcript and a recording of it, so it's open online if anybody wants to check it out. We had like maybe 30, 35 people come from the Bitcoin development community to learn about how Check Template Verify works, the applications of it, and talk about the ecosystem and deployment of it. Again, open workshops, so anybody could participate remotely or online, but people did come in person, which was really nice. And a lot of people got really excited about what Check Template Verify is bringing to the table.
Mm-hmm. Okay, so let's get into that. I wrote an article about this a while ago, of course, but let's start from the start. CTV.
Check Template Verify started as a research talk I gave at Stanford's BPACE conference back in 2017. And I think January 2017. And what I had talked about was, I said, hey, if we had these things called covenants in Bitcoin, we could do all of these really neat things. A covenant is any sort of restriction on how a Bitcoin can be spent, other than the authorization. So when I have a script for Bitcoin, an address, I have some public key, and then I sign for that coin, and then I'm able to transfer it to someone else, and then it's theirs. A covenant is sort of a higher order, automatically enforceable restriction on that. So an example of a covenant is this key can only spend after this much time has passed. So
like time lock is a time lock a covenant?
A time lock is a form of a covenant. As it happens,
so covenants already exist in Bitcoin then?
They do already exist, and there are basic ones that are just fundamental to how Bitcoin works. One is a covenant that says in a transaction, the total amount of the sum of the outputs must not exceed the sum of the inputs. So you can't create money in a Bitcoin transaction. And that's a little bit...
Even that would be considered a covenant?
It's a sort of covenant because it's a restriction on the type of transaction that a coin can participate in. And it doesn't really necessarily make sense to think of those as a covenant, because usually we're thinking about a covenant at a much more sophisticated layer. But what it is useful to sort of categorize these things is just thinking about them as restrictions on how and when and why you can spend a coin.
Right.
And all of the restrictions on how a coin can be spent start giving you a language to think about what covenants can and can't do.
Right.
And so that's why I like to think about, okay, well, there are already some existing covenants, and the outputs and inputs restriction one, maybe that one's not really super covenanty, but it does say like, look, you can't spend with another coin, that is less than the amount of value for this transaction. You have to be spent with one that's a little bit more. And when you get into covenants, a lot of what you're looking at is not having any new rule necessarily, but enforcing the existing rules in sort of a programmatic way.
Is this a general idea of what a covenant means? Because I was under the impression that when the term is used, it refers to something new that doesn't exist in Bitcoin yet.
Yeah, so the term covenant, I mean, just like peeling back, the term covenant comes from like legal contract writing. And you put a covenant in as any sort of general purpose, like promise that you're doing. And those promises usually come in a section that's like warranties and covenants. And there, one example where they're used in America that was not good is, it's local to me, it's a San Francisco thing that happened, is people would put covenants on their houses. So I would sell, like a white person would sell a house to another white person, but then they would include a covenant that says you can never sell this house to a black person. And so covenants can be used to say, like, look, through this series of transfers of property, we have to preserve this property. And so similarly, the reason why I think that something like a time lock is a covenant is I can send somebody given an address, and it, not just an address, like a SegWit address given like a public key. I can say, I've sent you money, but you can only spend it after a year. So it's a sort of a covenant where I've said, look, I've given you the money. It's definitely yours, but I've restricted somehow how you're able to use it. Bitcoin, we don't really like that kind of thing, because usually we're like, hey, you give me money, it's mine. I don't want you to have any further control over that money. So it's a very difficult concept in Bitcoin for people to really internalize, because we're so libertarian. We really want people to have control over their assets and be completely self-sovereign. So any system that says, hey, how are we going to add restrictions to how money can be spent, seems to be a little bit at odds with that. And there are types of covenant that people get very worried about that might have sort of a long-term negative impact on Bitcoin, where, like, let's say you were to have a covenant that says these coins have to be, you can move them to whoever you want them to move them to, but you always have to include a backdoor key that's owned by the government. That would make people really unhappy. So when we think about covenants, we can kind of partition them into different types that permit these sort of very flexible recursive systems that maybe like permanently attach a new restriction onto a coin, or we can think of them in terms of systems that give a user more control over their own coins. And so there's sort of some distinctions there. And check template verify is an effort to carve out a tiny sliver of covenant-like functionality.
Yeah, so just to make that clear, you're thinking of covenants as a very broad concept, and then CTV is one very specific example of a covenant that you're proposing.
Correct. Yeah.
Which would be a new opcode in the Bitcoin protocol.
Yep, that's absolutely correct. Another way of thinking, of this, or an analogy, would be looking at, like, just saying, hey, what's a computer? And if I pull out a calculator, that's a computer. If I pull out a laptop or an iPad, those are also computers. And check template verify is like a calculator. It's like a very rudimentary covenant. It's not like as sophisticated as a computer, and so the types of things that you can do with it are more bounded and well understood.
Mm-hmm. Okay, so what are the restrictions that you're proposing through this type of covenant CTV?
Yeah, so the main use case for check template verify is that you can essentially pre-sign a transaction. So if I were to send a coin to you and it goes to a public key, then you could say, okay, I'm going to sign a transaction that spends from that coin, but I'm not going to broadcast it to the network. I'm just going to put it in my desk drawer, and maybe I'll take out that transaction at some point later, or maybe I'll give it to somebody else and they could use it later if they wanted to. The issue with that is that you have to sign something, and all check template verify is saying is, embed that signature inside of the address. So if you have some pre-authorized transaction that you want to allow to happen just based on having an address, check template verify says you can just include that in the script rather than having to have a step where you go and sign to pre-sign the transaction. So that's all that it's doing is you give essentially like a literal transaction that you want to pre-approve, and then the coin can be spent exactly in that transaction.
Okay, so and what would be the benefit of this?
So the benefit of this is that you can use this as a building block to make smart contracts in Bitcoin. So if you were to take one of these check template verify scripts, one example of something that you could do is, let's say you're wanting to make an allowance for your child, and you want to give them 1 Bitcoin a month because, like, I just want good numbers, but you're also, let's say, fabulously wealthy and you're giving your child 1 Bitcoin a month. So what you would do is you can set up essentially an annuity contract that says, at the beginning of the year, I bundle up 12 Bitcoin, and then that goes into a single UTXO. And then once a month, it spits out a UTXO that is of 1 Bitcoin. And then the rest go into 11, then 10, then 9, so on and so forth until all the money's split out. And there's a time lock at every step.
Mm-hmm.
So what check template verify is playing the role of is it's saying you are encoding that backbone structure, that backbone recursive structure, as a series of pre-approved transactions for a single UTXO. And what becomes really cool is when you don't just have a single linear flow that things have to go on, but you have optionality. You have a path A and a path B. So you could say something that, let's say that you and your spouse have a, signing path that you can both do that's multi-sig, and you say, if the chores aren't done, we're going to take the money back out of this allowance. And so then you can have 2 paths. You can say one path is automatically that 1 Bitcoin a month gets delivered, or 2 of the keys come online and say, no, you didn't do your chores, we're taking the money back. But it wouldn't be just one parent has the authority to take the allowance from the child. And once you start building out these alternative pathways and flows, you start being able to build really sophisticated smart contracts that are still very limited in terms of the semantic that they're able to represent, but you can build very secure like wallet vaults and custody solutions. What I'm describing, as this allowance is fundamentally a wallet vault architecture.
Right. Couldn't this be built without CTV, just using regular time locks and regular multi-sig setup?
So you could. The way that you would be doing this today, there are 2 ways that you could do it. One is you could use pre-signed transactions. So you could send the funds to a single wallet, and then you could pre-sign a bunch of transactions based on it and then give those to your kid. Yeah. And they would be able to go and redeem. The issue with that is that signing step is interactive. So if your child doesn't trust you that you're actually going to, that you're not going to try and double spend, then they can't get a proof that there's no other way that the coin can be moved. So you could have some other transactions that you signed with those keys. And check template verify, what you want to be able to do is you want to be able to, let's say, show it to an auditor or show it to somebody who's outside of your setup protocol and be able to say this was honestly created. Other way that you could do it would be you could say, let's make a coin for each month and have an absolute time lock for each one that it's the first of the month. Or relative time lock. The issue with that is then you have to do 12 events on chain and they aren't serialized. They all happen independently. So if you want to have the property that you've built a control flow program where you have everything going through one path, then you need to use something like check template verify to move the funds from hop to hop, rather than having 12 different independent contracts that execute, not all at the same time.
So the other example would be to do the mempool smoothing out. Did you just give me this allowance example to showcase the diversity of your proposal?
So I think that people are excited about different use cases for check template verify, and I have my own sort of preferences of what I think is most impactful, but I think it's important, that people see that there's a diverse range of applications. The one that you're mentioning, which is kind of a congestion control mechanism, smoothing out the backlog.
So is that the one you care most about then?
I think that I care about both that and vaults. About, I love all my children. I guess that's what I would say. I care about both of those a lot. I think that the congestion control has the biggest propensity to kind of fix an underlying flaw in Bitcoin, which gets me really excited. But vaults, it strikes at the core of what Bitcoin is about, which is self-sovereignty over your assets. And I think that at a user level, it's just ridiculously empowering to have better tools around that. So that's why I get really excited about vaults as well. So, it's hard as like an engineer who's trying to get Bitcoin to work in its current form. Congestion control is really cool because it's like, okay, like we can ignore the backlog of transactions. It's like not as bad anymore. But then from a what do we actually want Bitcoin for perspective, vaults are really exciting to me.
Okay, so let's get to the congestion control example then.
So the basic idea is that if I want to pay out thousands of users in a single block, I end up having to pay a lot in fees because I am bidding, and I'm bidding against myself and I'm bidding against other people for that confirmation. The fundamental idea is to split a transaction into two parts. The first part is the spending of the coins, and the second part is the receiving of the coins. And if you split those two parts, you can make it so that all the receivers are guaranteed to get the money no matter what. And they can prove it to themselves. That's why that non-interactivity we talked about earlier is important. It doesn't really matter. They can just see the transaction and know that it's valid. There's no other way that it could be sent. And what that lets you do is it lets you have the mempool fundamentally have like two different bands of fee. One band of fee would be the market for confirmation, and that would be the market for fresh spends that are not somehow guaranteed. And then you would have a second market, which would be the market for redemptions, which would be at a much lower priority because people can wait on that money to become available. And
they can wait because they're sure they're going to get the money. There's no other place the money can possibly go.
Exactly.
And it can't be double spent on them in any way. Like it's confirmed on the blockchain, it's guaranteed to them.
Yep. It can be treated fully confirmed. So that it can't be directly spent without another transaction on the chain is sort of a funny point because you also can't spend a coin without a transaction on the chain. Like if you're trying to spend a coin, you have to do a transaction. So that all that Check Template Verify is doing in the congestion control case is saying when you go to spend a coin, if you haven't waited enough time for it to fully settle, it might be more expensive. Mm-hmm. But if you wait and you try and take advantage of a low fee period to do some of the less important work, which would be expanding out, the already confirmed things, then you pay a higher or lower rate. And so it's essentially making pressure to smooth out the utilization of the chain.
So the reason it would be more expensive if you want to spend it faster is because you got to pay for both the second half of the first batch and then your own transaction at once. Plus, if you want to spend it faster, the fees are probably going to be higher anyways, right?
Yep. And that is somewhat true. What's interesting that I was able to simulate in, I won't say prove because it's a simulation, but I was able to strongly demonstrate is that if you're a business and you have an outbound transaction load that is not uniform priority. So let's say you've got VIP customers and then you've got regular customers, and the VIP customers, you want to be able to pay out at one high rate. You can think of this like priority boarding on an airplane. They let first class get on first, and then, business class, and then economy. So if you imagine that you have 3 batches that you need to do, one for, first class, one for business, and then one for economy, it actually turns out using Check Template Verify, you can do that type of 3-tier batching less expensively than you could do it without Check Template Verify. So even in the case where you want to minimize both the on-chain space used and the fees paid, Check Template Verify helps you in either one of those regards.
And then there's the whole 3 payment structure you came up with. Can you get into that a little bit?
When we talk about doing it as just like a two-step payment, that's a little bit of a simplification. And I think that that is what's likely to roll out early days, as it's maximally compatible with existing wallet infrastructure. Because it just looks, if you don't upgrade your wallet, it just looks like a regular unconfirmed payment. So most people's wallets can understand this is a pending payment, and they'll spend from it, and they'll try and prioritize it, confirming by bumping it if they do a spend out of it using child pays for parent. So that's sort of an API that would work without much wallet infrastructure change. Further down the line, which would require maybe a little, just a hair more support from the wallets, you can have, instead of just part A and part B, you can have a tree. So you can say part A and part B0 and part B1, part B2, part B3. And then you'll have 4 branches out that you've done on the payouts, and then you can recursively apply that principle until you've covered all the people trying to get paid. And what this does is this makes it so that if you just did a 2-part transaction and there was 1,000 people getting paid, the first person who says I need to get my money out has to pay for all 1,000. But if you do this tree structure, then you only have to pay for the part that you're in up to log n of the work. And a quirk of how you sum up a structure like a tree, it turns out that the overhead you end up paying for versus no batching ends up being linear overall. So if you have 1,000 people, the cost is 1,000. And that's true whether or not you use the check template verify tree or not. But the benefit is that when you go to redeem your payment out of one of these check template verify trees, you individually are maximally responsible for log n. And for the listeners who don't know about logarithms, log is just really small. So you use a radix like or a base like 4, and if you had 1,000 people, it would be divided into 4 groups of 250. And this is really going to tax my mental math abilities here. 4 groups of 250, and then 250 to 64, and then 64 to 16, and then 16 to 4. And so you only have to go through a couple hops to get your, like, those are all constant size transactions that you're going through. Those don't have that many people. So you're going through like four transactions to claim your thing. And those are 4 transactions of size 4 each. And so that's 16 amount of work compared to 1,000 amount of work. So 16 is much smaller than 1,000. It also amortizes. That means if you wait longer, other people will have claimed, and then that prunes off things that you would be responsible for. And so the expected amount of work across all participants is just a constant amount. It's just a single O of 1 amount more per person individually. So it has a really nice property that sort of people who want more priority pay for it. People who can wait pay less. And that's how we want Bitcoin to work in a functioning fee market anyways.
The main benefits, to make that clear, is that in general, the fees that people would pay would go down because we can smooth that out over time.
Yeah. And I think that there's a really important point to make around fees going down is, if fees go down, does mining revenue go down? And what's cool is not necessarily, because a congestion control scheme is a device that allows more users to use the system. So what you're saying is at the high fee, really high demand periods, we're going to smooth that out and push that transactional load into the lower fee time periods and lower demand periods. And so the total revenue should at least be somewhat neutral, because there's still like whatever fundamental amount of demand. It's just you get rid of peaks, which are bad UX and drive users away, because businesses need to rely on being able to make and clear Bitcoin payments. And if they can't, that imposes a damper on adoption. Then the other thing that's nice is when more people can rely on Bitcoin, more users will show up. And so I think that overall, this will just sort of point to Bitcoin as being a more reliable system, and we'll see more adoption as a result, which I think is good for, like miner revenue longer term.
Yeah. You already mentioned it briefly, but how would how would it change from a user's perspective? So at first, the way you see it is in a user's wallet, these covenant type of transactions, if they receive one from, say, an exchange, would just look like an unconfirmed transaction. Is this how you envision it long term as well, or would there be some sort of intermediate step between confirmed and unconfirmed, or how would you envision this?
So one thing that I'm sensitive to is the 80/20s of any technology. And that's the 80% of the benefit for 20% of the cost. And I think with CTV, you have a lot of really good 80/20s. So if exchanges who have lots of payments just were to say, look, we don't care about these payment trees. All we're going to do is issue a route that commits to a single next transaction that pays out everyone. That's all that we're going to do. And that next transaction, we are personally going to guarantee that it gets confirmed within, let's say, 1 day. So then from a user perspective, without any change to their wallet whatsoever, they would just see a transaction that took a day to confirm, which is what they would see anyways, right? If an exchange was not paying sufficient fee because they were too low in the mempool for their thing to get confirmed, they would already see something that just took a day to confirm.
Yeah, well, what's the only difference that most exchanges, as far as I know, do pay enough fees right now to have transactions confirmed fast? That's why we see these spikes, for example.
Yep. So they do pay enough right now, but across all businesses and all users of Bitcoin, that can't be the case. Like, obviously, some users are going to be, lower, and it creates like a less just system because people don't get access to the confirmation market, which the confirmation market is really critical. The sooner that Bitcoin can clear and settle like non-negotiably funds being transferred, the better. It's good for because like, you put it behind more proof of work. There's less sniping and reorg incentives and things like that. So it's really good to like get those payments committed earlier, no matter what. But that redemption market then becomes more differentiated because anybody can clear an O of 1 transaction at the top of the mempool. That's always going to be relatively cheap compared to clearing thousands of users. So I think any business should expect that that's what they should have to do at any time. But it's not. It ends up like their volatile fee exposure ends up only growing with the rest of the market rather than with how many users they have. So they're now decoupled and they don't have sort of a fundamental bottleneck on how many users they can support on their platform, which is I think a strong outcome.
Yeah. So let's get back to the question. The user would see it as an unconfirmed transaction.
Yeah, so I think at first the user would see it as an unconfirmed transaction, and the exchange would take the responsibility for confirming it fully within a reasonable amount of time, let's say a day. And so what they would be essentially betting as the exchange operator, they would say, I bet that within a day there will be a block that pays a lower fee than the current one, and I'll be able to get my transaction in.
Sure.
Right now, it's a pretty reasonable assumption. And users' wallets would see an unconfirmed until the exchange drives it to completion, and then it would become fully confirmed.
Or until one of the users uses child pays for parent to speed it up and pays
exactly.
A bit, presumably.
And that points to an interesting thing, and the mempool doesn't work for this right now, but there's sort of a cooperative fee sharing thing where if, let's say, 5 users all add a little bit of fee as a child pays for parent transaction, then that aggregate package accumulates, value. And
sure.
So everybody can cooperate to drive up the total amount of fee available in that package. And there's some sort of nice cooperation that can go on where, right now it's child pays for parent, which means that you only track the best child, not the aggregate of the children. But there is something that can happen where you're looking at all of the potential children and figuring out what's optimal. And I'm excited for that sort of technology to maybe make its way in.
Child pay for parent.
Eventually, what I think you would see from a user wallet perspective is wallets will understand when they're receiving from a check template verify address or from a check template verify output. And they'll be able to just say, oh, look, this is a confirmed fund. And if I observe on the network that fees are low, I should try to drive it to completion so that I pay less fees later on. So they'll just sort of like be arbing the fee market, which is, again, going to be good for stabilizing that. When they go to spend, they'll look at all their available funds and they'll take out the least expensive one to spend at that given time. Wallets will, I think, start having, and they already have some notion of this. Like if you have a multi-sig coin and you have a single sig coin, the multi-sig coin is more expensive to spend. So if you're trying to minimize fee rates, you'll pick your single, key ones before your multi-sig ones because it's going to be less expensive maybe. Unless it's a low fee period, then maybe you'll prefer to do the multi-sig ones. So I think wallets already need to understand this. It'll just get better.
Yeah, so it sounds like you think it would be mostly abstracted away to the background.
I think so, yeah. The one thing that changes is data storage. People right now just assume that the blockchain stores all the data for them, but we kind of already know that not to be true with like Lightning channels, that that you have to store some of the data yourself. You also have to store your own copy of the blockchain. So there is an additional point, which is that the blockchain and the blocks themselves stop being like an available data storage for all your transaction details. You really do need to store transactions that you've received yourself, or use a watchtower system or something to keep those details. That's the one other change. You need to back up your wallets.
Right. You already mentioned Lightning very briefly. I think there are benefits for Lightning as well in this CTV context, right?
Yeah.
So that's about funding channels.
What I love about CTV, and this is just a property of it, is the contracts that you write are really composable and they're non-interactive. So what that means is if I'm talking about, hey, look, here's a cool annuity contract that lets you do an allowance for a child, I can take that and then I can plug that into an exchange and say, pay out to this allowance directly. And then it will fund an allowance contract with no intermediate step. So I don't withdraw from the exchange and then put it into the allowance contract. I can immediately do that. So with Lightning channels, you can make a non-interactive Lightning channel. So what that means is I can take a public key that I know for you, and I can create a channel with whatever initial state I want to. Maybe I make it with a payment. So it's like you get half a Bitcoin, I get half a Bitcoin, and then that's the initial state. Maybe it's I own all the Bitcoin and I have 1 Bitcoin, you have 0 Bitcoin in the channel. Or maybe you have all the Bitcoin and I have 0 Bitcoin. Whatever state I want to, I can create a channel without talking to you. And then I can show this channel to you, prove to you that it was correctly constructed, and then we have a channel to work with. That itself sounds like not the biggest deal because Lightning already works with an interactive protocol. So why do we need this? What's really cool is I can take that Lightning channel address that I created and I can give it to an exchange, and then they can create a channel for me, not knowing that they're creating a channel for me. Now, and this is sort of like the building picture that I want to give. Now, what happens when I create that Lightning channel and the exchange says, ha, sucker, we put it at the bottom of this tree and it's going to take, you're probably going to redeem this, like a month from now. Well, okay, but I created it into a channel so I can immediately begin to route it across the network because the channel is fully confirmed that it will get created, fully operational. The market for redemption can happen whenever, when I need to close the channel or just kind of passively as time goes by. But now I have a channel that I can immediately begin using. And so what this does is this creates a huge new gateway for the Lightning Network to get deployed.
Mostly it's for people to start using Lightning faster. Would you say that's the main benefits?
I think so. I think that, there's like 5 different ways that it affects Lightning. And I think, the sort of most obvious one is like, it just makes the protocol simpler because a lot of the handshaking that you have to do to open a channel is kind of difficult. It's nice to just be able to non-interactively open a channel with somebody and be like, here's a channel and it's usable. Mm-hmm. But then in terms of bootstrapping, it means that you get a 2x benefit of not having to do the step between an exchange of like, hey, please create a channel for me. No, exchanges don't support that. So you have to like move the funds into your wallet and then into your channel, right? Now you can just say, hey, please open a channel for me. And by the way, you don't have to even know that this is a channel that you're making. I just said, pay to this address. And once that address receives the correct amount of coin, it creates a channel. So that to me is what's like just remarkably powerful. And I'm really excited about it because that's going to make it so that the Lightning Network can bootstrap itself much more quickly.
Yeah, it's a bootstrapping shortcut in a way.
And you can also imagine a scenario where, like, let's say the network has a big imbalance and you need to open up like 1,000 new channels in order to like add new routing capacity. Now you can open those channels like that. It's just like incredibly fast that you can go and say, okay, I need to open 1,000 channels, but it only costs you at that time O of 1 on-chain space. So just a constant small transaction to open up all those channels.
You used to call this proposal secure the bag. Why?
I did.
Why did you change that? What changed?
It's gone through a few different naming iterations. So before it was secure the bag, it was check outputs hash verify. I gave a presentation on that at the SF BitDevs, and a good number of people said, what are you doing introducing Koshvi? Are you hyperbolic cosine or something? Like, we don't want that. That's a bad name. You should name it something more fun. And so I said, okay, I like fun names. I just wanted it to be boring. So it was uncontroversial, but like, I'll pick a fun name. So I think I was talking with some people and they're like, okay, let's call it secure the bag. And there are a few reasons for that. One reason is that it is sort of like secure the bag means like get what's yours, get what you need. And that's what check template verify is doing for this congestion control use case. It's saying, get that confirmation, get that money, get it faster. So secure the bag. So I like the name for that reason. It was also at the time a little bit of a meme with Andrew Yang, where it's like, hey, Andrew Yang wants to send $1,000 a month to every American. If you wanted to use Bitcoin to send a Bitcoin, like a year to every American, how would you do that? Well, you would want a congestion control thing so that you can just send everybody the money in one constant size transaction and let them worry about redeeming it on their own time. So it was kind of nice for that reason as well. And then there are a few other reasons that I just really like the name as like fun and approachable and kind of brings people in with a pop culture reference. There's some good music around it. So I was happy with it. And then people were like, hey, you're not taking Bitcoin seriously. Bitcoin is really serious. Like, you need a name that's really boring and like just describes what it does. Like, I don't get why you have secure the bag. Maybe also it's too political. And so then I was like, well, like, I don't know. Like, I already changed it once because other people said it wasn't fun enough. And then eventually I said, okay, look, I just want to get the technology out there. I don't really care what it's named. Let's call it check template verify. And the reason for that name is it is relatively boring, but like technically correct on what it's doing. It fits in line with like other opcodes that exist in Bitcoin. And there's sort of a nice metaphor where it's not only check as in like, confirm, but check as in like a paper check that you're writing. So it's a template for a paper check. So it's just saying, here, fill in, who should receive this $1,000 or fill in who, who's sending. And so it's sort of a template for a check payment. So that's sort of the niceness of the new name. But some people still like calling the technique secure the bag. And, I think that will never go away. Like I one person told me, no matter what it gets renamed to in the BIP, I'm calling it secure the bag in our code base. And I'm like, all right, like you do you. That's the beauty of the Bitcoin community.
I think the main critique on the proposal, but correct me if I'm wrong, is, well, it's mostly some developers think it should be more flexible, or maybe others think it should actually be more strict. Is that right? Like, is that sort of the debate on how flexible or how strict the exact limitations should be?
You can think of covenants and really, covenants just encompassing like all programs possible for like value control. So as being this big circle. And in that circle, there's like Bitcoin script and there's, the Ethereum virtual machine and, there's whatever you could want. And what I did with check template verify is I drew a really small circle and I said, this small circle has a lot of really cool things in it, but it's really small. And so what people are generally, doing is they're saying either the circle should be smaller or it should be bigger or it should be slightly shifted over somewhere in some way or another. And there are a few restrictions that I kind of agree like could be safe, that could be lifted. And I have lifted some of those. In an earlier version of the proposal, it was like very, very strict. I made it a little bit less strict.
Okay, give an example of this. How would it be less strict or?
Previously, I had it be the case that the pre-approved transaction that you were using had to be a literal inside of the script. So it couldn't be computed from other data. I got rid of that restriction. So now you could write a script that contained the exact transaction as like a literal, and then you hash it, and then you check the template verify. So that would mean that it's computed from data that was in the script rather than from just like a literal, like this is a hash that you should be checking this thing against. And that opens up the door to, in the future, if something like opcat were to be added, then you get a really powerful covenant language inside of Bitcoin. But I wanted to be cautious, and I wanted to make it so that nobody would be able to say about check template verify, we don't want check template verify because if we add opcat later, then we're going to get all this extra functionality we didn't want. I wanted them to be able to evaluate check template verify completely in its own bubble and just say this is only going to impact check template verify and no other possible proposal down the line, which was one of the things I cared about.
Do we need to know what opcat is, or is that a side street we should leave alone?
Opcat, it just concatenates two strings together.
Right. So if you have a string that says 1, 2, 3 and a string that says ABC, it becomes a string 1, 2, 3 ABC.
Yeah. And it turns out that opcat, even though it seems really simple, is probably one of the most powerful opcodes to have ever been in Bitcoin. It allows you to do just like a remarkable amount of things for how stupid it looks. And it also exposes Bitcoin to a remarkable amount of security vulnerabilities. Because if you have a script that is a sequence of op-dupe, which doubles the thing that you have on the stack, and op-cat, op-dupe, op-cat, so on and so forth, it turns out that you can allocate like terabytes of memory and crash all the nodes.
Yes, and these were in Bitcoin at one point, and this is why they were removed.
And that's why they were removed, exactly. So there are proposals for like re-adding something that's similar to opcat that has like a more limited semantic, which I think at some point might go through, and check template and verify in its form
so why exactly from that. Why exactly would opcat be a problem in combination with CTV or a version of CTV?
Yeah, so the reason why is that as I think we mentioned earlier, with check template verify, it's really careful to introduce this very limited set of covenants we think are okay.
Mm-hmm.
If you had opcat, you can now start dynamically computing these pre-approved transactions, and then they become like you can add things or remove things from them. So an example would be with check template verify right now, it's just like, here's the exact transaction I want it to participate in. But then if you have opcat, you could say, but allow somebody to add any output they want to it. Or, allow somebody like, here are the exact, outputs that I want, but now allow anybody to add additional script conditions onto any of those scripts inside of those outputs. And so maybe there's some like bad things or things that people don't want that could be possible if it were to get added. Personally, like I'm in the camp of like, within reason, like the more the merrier. I'm happy with it, but I wanted check template verify to be able like, and that's where I have to separate my own personal opinion versus like what I'm trying to do with consensus is I want to get the feature in a form that Bitcoin can accept globally. Mm-hmm. So I pared it down to something that's small and approachable, even though there might be other applications that fit outside that boundary that are possibly safe. I think what's interesting is it's a little bit like poetry, where when you bind yourself to a specific format in verse and rhyme scheme, you actually sometimes become more creative and you deliver things that are more powerful because you have something, some framework to work in. And what I found with check template verify is that even though it's a small circle, once you adopt that mindset of how it works, you're able to make contracts that are just like remarkably powerful. And so a lot of the issues with it being not flexible enough, I've personally found that I've been able to get around any of those issues in a reasonable enough manner. But not everyone would share that opinion.
Right. Well, so how widely shared is that opinion in your perspective? You've drawn this circle. What do other developers think of this circle in general? Like, I don't know. You can give me a rough estimate.
So I think that I am still in the process of like building more awareness. I have been building a programming language for check template verify that if you want to compare it to like miniscript, miniscript operates at describing the key layer. So you're saying, if you think about like your daily commute in miniscript, you are describing your house key, your car key, your bus pass, and your office key. The check template verify language is describing the commute. So it's saying, go from your house to your car, start your car, drive your car to the bus station, take the bus to the next town over. I don't know why you're doing that, but like you're doing that, and then go to your office and then unlock the door, right? So check template verify is, in the language around it, is describing these commutes in the flow that you're doing. And so I've been building this language that allows you to write these higher order programs and abstractions around the flow of funds. And I've also been building out a litany of examples built in that language. And once I'm able to get that polished and released, I think what that's going to really show to people is that check template verify is really flexible and you're able to build a lot of applications on top of it. And people are going to be able to experiment with it and play. And I think play is incredibly important for getting people sort of excited about the flexibility of the system. But until I have that ecosystem such that people can get it started and play with it on their computer in a minute, like it's just not going to be clear to people. They need something very concrete.
Yeah. And to actually get this into the Bitcoin protocol, it would be a soft fork, right?
Correct.
So that would ideally, I guess, require the support of Bitcoin Core and miners. I mean, there's the alternative of getting, UESF out there or something, but I guess you would prefer it to
Yeah,
be implemented in Bitcoin Core at least.
so I mean, the Bitcoin Core question is politically contentious. I think it's something that the community is currently evaluating, is like how and when and why. And I think the general consensus from Bitcoin Core developers is that core developers want to have minimal authority around these things. So I think that, and not everyone agrees. I mean, I've been having a lot of conversations around this. Some people are saying like BIP9 is a failure and we should definitely not ever repeat BIP9.
Yeah, to be clear, BIP9 is just the 95% hash power enforcement, right?
Yeah, it's the signaling mechanism that was originally proposed for a SegWit. Other people are saying like,
you're right, it's not even enforcement, it's signaling. And
there's a lot of complexity. It's also like it's not 95% threshold, it's actually like 85% if you do the math out, because
eventually, because of luck, or is that not what you mean?
Yeah, because it's like in any 2-week period over the course of the year, and that means you've got 26 rolls of the dice, and that means that with 85%, you're almost guaranteed to activate in the course of a year. So the actual math ends up being like not completely intuitive, because it does require 95% in one period, but mining's a probabilistic process, so it ends up being 85% or something like that.
Right. So do you support BIP9, or how do you?
So
what are you thinking?
So
how would you like to see CTV being rolled out?
I think that the thing that has to happen is that people have to just universally in the community just be like, yeah, this seems like a good idea. That's like the first step that I need to bridge that. And I think that we're approaching that for CTV. People are understanding it more and more. There's software being written, like Vault software by Brian Bishop, that's openly available, that uses CTV. So I think that gap is going to close. But the activation mechanism stuff, I think that there's a lot of sort of like navel gazing around it, where it's a really hard problem and people are trying to learn too many lessons from the past. Whereas the lesson from the past isn't about the general nature of activations. It's literally about how did SegWit get activated. And I don't know if the lessons around SegWit, which were happening at a very contentious time, generalized to what's happening right now. So in my view, I think that, the simplest thing is just to throw it behind version bits BIP9. The code's already widely deployed and understood. So this isn't a really controversial change. So if that were to happen, then I think it would probably be okay. But some people really feel that we need to reevaluate these mechanisms and we should be going for something else. We should be going for BIP8. We should be doing a UASF. We should be just doing a flag day. We should, there's a lot of diverse perspectives in the audience that I've spoken with about this. And I don't know how to reconcile that.
BIP8 is where you either require hash power majority or a flag date. Is that BIP8?
I forget. It's like there's also there's just a lot of different proposals out there. There's also Matt Corallo has a new proposal he posted on the mailing list that he's working on. That's like BIP9 and then 6 months to figure things out. Yeah, and I have some theoretical work around this too. That's trying to look at the incentives of hey, actually these signaling mechanisms are not costly signals. People actually do have incentive to hold out to get more political influence, and that's not great. We should figure out a way that makes it so that if somebody chooses not to activate a rule, they actually have to have a real cost of why they're not activating it. And so my proposal is if you don't want to activate it and you mine a block that activates it, you have to throw away that block. So for somebody, they have to actually be committed to saying yes, this is actually bad for the community and bad for the ecosystem. And then over time, those thrown away blocks, let's say one every 6 months, they don't really matter because difficulty adjusts. So it's just it's just another invalid, proof of work block. But it's difficult to get everyone on the same page of what the right coordination is and what the right set of actors are to activate something. I know some developers are purposefully for other changes in the ecosystem just saying I'm not going to voice any opinion at all. I'm just going to work on the code. I'm not going to talk about deployment at all. That's going to be completely on the community's job. And I don't think the community has internalized that as like what's happening either quite yet. But that is, as far as I understand, what's happening with some of the other proposals.
Right. Well, and that's the activation specifically. Is your intention to get this proposal implemented in Bitcoin Core? Yes.
I mean, I think that like Core has to implement it if it's going to become a network rule. So that is my intention. I would like to. I mean, I would like to. There's the thing that's hard in an essay I would recommend to anyone is The Tyranny of Structurelessness. If you've not read it, it talks about sort of like anarchistic communities and how an aversion to forming hierarchies and like power structures ends up just having power structures that are not transparent. And I think that that's a little bit of where we are right now, where nobody really knows like what is necessary. And at least in my personal psyche, that's like really hard because like I would love to just like do the thing that's like non-controversial. That's what I would do. But then there isn't even that thing, and you don't even know who you're supposed to talk to or who you're supposed to like, you know, there's no putting out a letter and getting people to sign it. Like people would say like, that's not the right way, or this isn't the right way. And so any form of coordination, Bitcoin as a community is just kind of allergic to. And I think that there's a real risk to the community of like, where I think that there's a bit of a focus on like ossification as being like a strong goal of the ecosystem, of like freezing, the way that it works and getting things like locked. I actually think that that's the most dangerous thing for Bitcoin to do at this time, because I think that we're looking at like the ecosystem as a whole and we're saying we're doing pretty good, and we're doing pretty good even though we're the least flexible project and we're not rolling things out quickly. So let's keep on doing that. But I think that we haven't put our sights heavily enough on the ecosystem outside of the crypto sphere and saying how do we actually compete and make Bitcoin deliver a self-sovereign financial layer for the world. And I think we focus too much on crypto project A, crypto project B, when we need to focus on the outside world and how we're competing at that layer. And we still need a lot of technology progress before we hit ossification. I think if we're going to clear that hurdle, that's just my opinion. But I am worried if we can't coordinate around actually like making progress towards that in a reasonable timeline, that our competitors outside the bubble are going to eat us.
That's very interesting. I know you have a hard stop in like 2 minutes, but we should continue that discussion sometime. To close this discussion off, what's the near term plan? How do you see what's your plan right now? What are you going to do? How are you going to get CTV deployed if that's the idea?
So I am.
And how long would that take?
The programming language for CTV polished up and deployed. If anyone listening is like really interested in that, definitely reach out on Twitter. I'm at Jeremy Rubin. You can get a lot of resources at utxos.org. I'm trying to get people educated and aware, informed, and decide for themselves if CTV is something that they want, and then communicate that back into the community, so that we form that broad social consensus that this is a change that people are excited about and need. And my efforts are primarily in just getting the technology to be really freaking good and getting people to be self-sovereign over their assets and get Bitcoin to scale. So I think that at the end of the day, that's what it's all about, and that's what I'm here to do.
Jeremy, thanks, and good luck with CTV.